Three, two, one.
Hey everyone, welcome to the official Cloud8 YouTube channel. Cloud8 is a robotics team that is based in China, and we compete in FTC, which stands for First Tech Challenge. We are probably the only team in China that is not school affiliated or organization affiliated, as many other teams do so. In today's video, we're going to introduce our robot and how it works. First, we have an intake system. For our intake system, we have a 3D printed and self-designed claw that is attached to the robot through a virtual forebar. The virtual forebar allows the claw to stay parallel to the main axle. Our claw is powered by a servo that allows it to open and close. And on our claw fingers, there are two ridges, one on each side, that match the interior of the sample, which allows it to pick up samples easily. Our bucket is also attached to a servo, and after our Viper side has reached the desired height, or the height of the high basket, we can power the servo, making the basket go backwards, and letting the pixel fall into the high basket to score. At the back of the Viper side is the specimen claw. The fingers of the specimen claw allow it to grip specimens easily, like so, because it fits the interior of the specimen. The way we score them is again to use our Viper sides. Raise them up, and then clip the specimen onto the high chamber, and then release the claw. The wheels on our drivetrain are built as omnidirectional wheels, which means that our robot can go in any direction we want. They are connected through a pulley which connects to a 312 RPM motor, and we put all of these motors on our base, on the bottom of our robot, to save space. Two more motors are on the bottom of our drivetrain. These motors are for powering the Viper side, and these two gears spin in the opposite direction, transferring the power to the third gear, which connects to an axle connecting both of the Viper sides. This allows for a much faster and more efficient Viper side raise and drop. We also included 3 odometry wheels for navigation in the robot. All of these motors are put on the bottom of our robot to save space, meaning that we can put more things on top of the robot. And this also allows us to have a stable bottom, as most of the weight is centered on the bottom.